All right, good morning, hello, and welcome back to Mr. Reed Math, where we're going to take the mystery in math and make it past tense. And this is officially my second video in the 25-26 school year. We are still working with Greek construction. This is now part 2. We just did how to create another line segment of the same length. Now we're going to do something that has to do with Euclid's proposition number 10. Okay? And what we're going to do is we're going to take a line segment and we're going to create a perpendicular bisector. Let me explain real quick what that means. You take a line segment, okay, here's A and B. Perpendicular bisector, there's two good vocabulary words. Perpendicular means 90 degrees, means when it crosses through, it's going to be a 90-degree angle. Bisector means it divides it into two perfectly congruent sides, okay? It's going to, so like you get that point, it's going to be right in the middle. And whatever this length is, this is going to be the same, right? These are going to be two congruent smaller pieces. Perpendicular means it's going to come through, it's going to be 90 degrees exactly. And somehow the Greeks were able to do this without a ruler, all right? They used just a straight edge and just a compass. All right, now here's what the sheet looks like. And I'm going to go through this process. And then after that, you'll have 2 practice problems to do down here, okay? There's those 2 right there. All right, so here we go. Now let's do it for real. With the straight edge, get a nice line segment. Put 2 dots on the end. That's point A, that's point B. All right, now what I want you to do is kind of in your mind, I want you to imagine about approximately where the halfway mark is and approximately where 3/4 of the way across is, all right? And I'll show you why. You take the sharp point of your compass, put it on point A. All right, and then I'm going to bring the pencil back to approximately it doesn't have to be exact, but approximately the 3/4 mark, okay? And then what I'm going to do is I'm going to draw an arc above at about the middle, and I'm going to draw an arc below at about the middle, okay? So do you see how I got a little curve there and a little curve there? It's a little faint on the video, but I think you can see what's going on. Now I'm going to put the sharp point of my compass here on B, and I'm going to do the same thing. I'm going to put that little arc up here on the top and a little arc down here in the bottom. Okay, and if you hear snoring, that's my dog. That's Hulk. He snores. All right, now where these 2 little arcs cross, I'm going to put a dot right there at the intersection. Okay, and where these 2 cross, I'm going to put a dot there. Okay, now we have a point. And right here, actually I'm on the wrong, oh yeah, there it is. Okay, I'm showing you the wrong one. So we have a point X and a point Y. So up here, that's point X, and that's point Y. And then what I'm going to do is I'm going to connect them. And as soon as I do that, there's your perpendicular bisector. Okay? I'm going to put an arrow on that and an arrow on that. I'm going to call that line XY. And this allows me to write a really cool statement. All right, stay with me. Check this out. I'm going to say line segment AB is bisected by line XY at point, oh, we need a name for the point. I think here it says call it C, at point C. Okay, and now knowing that, I could call that, this length right here, if I called that 5, and if I called that X plus 1, what's the value of X? Well, now I can determine that because I know that both of these are the same. It's been bisected, okay? So because I know they're both the same, I know they're both congruent, then I can set them equal to each other. And I can say X plus 1 equals 5. Subtract 1 from both sides. X equals 4. I can solve for X. All right, really cool feature. When you can prove that something's a bisector, that's a really strong statement. That's really useful information. Okay, so there we go. Now we've proven, we've demonstrated Euclid's proposition number 10. And so you're going to do the same thing with these 2 examples down here. Okay? All right. Now the next one, go ahead and pause the video if you want to do that and hit restart. Okay. Now, we're going to go into Euclid's proposition number 9. Okay? And if I got, yeah, this is the right one. We're going to bisect an angle. Okay? Let me get rid of this sheet. And the way we do this, basically, I'm probably going to draw it, because I'm right-handed, I'm going to draw it this way. Okay, so if we have an angle, I want another line. There's the vertex and 2 points on the line. We could name that as rays, however you want to do it. But now I want another, either a line or a line segment or a ray or something that goes through, and it divides these into perfectly even or perfectly congruent angles. Okay, now you can tell when I did that by hand, it didn't really turn out very well, did it? Okay, but Euclid's proposition 9 hooks us up and makes it really easy. So I'm basically going to follow all the same steps here. All right, I'm going to draw it from scratch here. I'm going to draw one line segment, and I'm going to draw another one connected at the vertex. Okay, I'll put a point there, and it looks like in the bottom instructions we want that point to be called X. Those will be a ray. Cool. All right, now what do we do? How do we get started? All right, well, what I want you to do is you're going to take the sharp point of your compass and you're going to put it on the vertex. Okay, and it doesn't really matter where you set the pencil. It'll work for pretty much any setting, but I'm going to keep it kind of close to home, probably about halfway down the ray from what I've drawn. Okay, I'm there, I'm happy with that, so I'm going to keep that setting, and I'm going to draw an arc right there and an arc right there across each ray. Okay, and what that's doing, once again, the properties of a circle, because the radius is always congruent within the same circle. Now I've got 2 points that are exactly the same distance from the vertex. Okay, and I can call those points according to the exercise. I'm going to call that one D and call that one C. All right, now here's what I'm going to work from. Now, if you moved your compass at this point, it's okay, because now we're going to do a completely different setting, and we're going to use both of these points to do it. All right. And what I do is I put my sharp point on one of them, and I want to go about maybe a little bit more than 3/4 of the way across. Okay, and I'm going to use that to draw an arc out in this area. Okay, now don't move your compass at this point. You need it to stay the same, because you're going to do the same exact thing from point D. Okay, and I'm going to draw that arc so that now I have a radius from this point that's the same as the radius from point D. Okay, and where they cross, you might be able to guess at this point, that's the point that's going to help us bisect this angle. All right, so now all you do is use the vertex and use the point you just made, and you connect them. Okay, and there you have a bisector of the angle. Now these two angles are congruent. All right, they're the same. Voila. That's Euclid's proposition number 9. Okay, really cool features being able to do these. Now what I want you to be able to do for the rest of your time here is you complete these 2 example problems, and then you turn this last sheet over, and then you have 4 more that you're going to do. With these top 2, once again, you're going to do proposition 10. You're going to get the perpendicular bisector for these line segments, and then you're going to come down here, you're going to do proposition 9 again. You're going to create the bisector for these angles. Okay? Once you're done with that, that's 10 things that you've done. Turn them in. That's an awesome Friday. Thank you very much. Have a wonderful time.